Hello. Hello. Currently looking at a map of Argentina, the Falkland Islands. South of that is where A23A, a massive iceberg, has made its squirrely way from when it broke free from the 80s. The reason it's probably getting so much traction is due to the massive amounts of ice that has been lost. Turns to fresh water, it makes little pushes, little waves up, and pushes icebergs around, and a lot of fast ice. A lot of ice that might freeze again, but we're not going to see exactly the same areas because, see if I can get this. A lot of cloud obscurity. Okay. This side right here. This image is from the 27th. But there are sizes of ice that have been has been lost that you can only measure in the countries, right? And I don't mean European countries. These things are massive. It's not exactly what we're talking about here is the sea ice extent, which would be if Antarctica is the person, the sea ice extent is the kilt. And think about it in that way. And you definitely don't want to lose that kilt. I don't even want to try to get into that as a analogy. No. But what we're seeing here are some really radical changes in ice, sea ice, above and below the line of Antarctic. You can call it what you will, South Pole. It really is this land of frozen ice. And probably it's the most frozen fresh water on the planet. Adding this, now let's stop using that because it's too much cloud purity. There, that's what you want to see. You want to see that ice. But this area that we're looking at here, let's see if it comes up. Yeah, it does. You see this area here? This is the latest significant loss of ice in and of around Antarctica, below the line of the Antarctic. This was first. And I got out of here. It gets taken out of here by currents. And since it's all surface, it's just going to be rapidly, you just take it right out. And you start losing too much of the kilt already in here. Now this area here is breaking apart. Is in previous videos that I've shown, you see this huge fracture, and then everything becomes these pancakes, and pancakes of ice get taken out to sea. Push play. So it's just all this ice is here waiting. And it's going to be floating, and it's going to meet these currents. and these currents pull. These currents pull, and eventually, when the rest of this ice breaks, it's going to come out just the same as this did up here on the north side of it. We know that because in a previous video I showed how this was the first to go, and this is becoming the second. It's no telling the thickness of the ice itself from what we can just see on the surface, and could be significant, staggering amounts of ice and fresh water that's entering into the sea. You don't want it to have enough fresh water that melts into the Scotia Sea that pops it. Now, there is sea walls, and you have the deeper oceans. So having the sea with this giant, massive, which is called, we'll look at in a minute, A23A. It is a massive iceberg that's 80 kilometers wide or 50 miles wide. Let's go back. There it is. Wow, yeah, it's really made its way up there into the Scotia Sea. A lot of great definition. You can see on this thing how hardened it is from fighting monstrous adversity and the amounts of over 80 plus kilometer winds, different temperatures of water that it's wading in through and out, colder to warmer, and this thing is becoming like a tooth in sugar. It eats away at it, and there's nothing you can do to stop it. You just want to stop eating sugar. But that's not going to happen, is it? It is becoming quite eroded. I don't think this is going to melt all at once. It's going to find a way, though, anywhere that's land and hit it. And this thing could be a ginormous threat to penguins and other kinds of beach life, like penguins. Just say, because I said it once, 74 kilometers. Not 75 kilometers, but it is the thickness that is not known. We don't know. We can only see just how much it shoots up from the water. But unless we can see its bottom, which even then that would be telling, because let's do something different today. Now we see here this is A23A here. We do not know just how deep it goes, how far down it goes. Is it going to approach and hit rising floor before we figure this out? It's a really important question. Just how thick is this ice? Why it hasn't melted yet? Because if it's 100 feet, 200 feet. We don't know. But if it's saying it hasn't been rolling over, so it's not rolling over, that tells me one thing, that it is longer in width than it is thin. If this thing was as long as it was wide, or even close to it, we would probably see this thing roll over. We have not seen this thing roll over, and it's gone through some fast water, and it has very unique features that distinguish it, besides this little armchair rest here. Let's say that this thing is actually 300 feet. This is coming into open waters, and it's going to be quite hazardous to anybody that is sailing any kind of research vessel or even cruise ships. Cruise ships that go south of Argentina and the Falkland Islands to pick on all the birds that lay eggs there. This is the defining feature. This is how I know this thing has not tilted. This iceberg has not gone anywhere. It has been just one side even, not size. While it has been deteriorating due to a lot of different conditions that it's finding itself in, especially in warming waters, is it going to fail from the bottom up to the point that by the time that we get any research on this, that it's going to be moot, since it's melting from the bottom up and it's wanting to turn, but it's too deep. If it were much shorter, we would think of it like a ship. It would just careen and flop around. That's not happening. This thing hasn't been moving in any way that tells me that it's not very long. That this is huge ice, and it is moving into island territory, the South Sandwich Islands. There is speculation from me earlier in the year that this caused an earthquake around the same time, where it stopped on hitting ocean or seafloor, or a rise in the seafloor. And after it got out of that little hairy situation, it hasn't stopped. It's also teeming with all other kinds of ice. See, it's warming up, especially the Great Lakes too. There's not a lot of sea ice when it comes to the Great Lakes. Now, the Canada, that would be... Yeah, this is looking bad. So you get this separation of ice from the continent. And, you know, I don't want to be grim about it. Push play. You see there? The huge cycle of ice cracking and then hitting each other. Sorry for that clap. And then getting moved away. And that is getting hammered into itself by bumping other pieces of ice of different thickness and density, that eventually it gives, you get another fracture, another crack, and it really comes out of that fast ice that is connected, and then it gets pulled away. But this isn't that, because it's all of this ice, the sea ice, becoming liquid. Sea ice extent Then you get this huge gap between the continent of Antarctica and the sea ice extent. This could be due to a lot of different reasons. One of the biggest theories that I would support is that the water and water ice that is coming off the surface of Antarctica is creating this little more like a shield, or no, more like an inverted vacuum, and it's just pushing out everything besides and it kind of cuts into the ability for the ice to reconnect and refreeze in a timely manner, because the water that's running off the surface of the continent is possibly warmer than the water and the ice that is meeting, causing this avalanche, this slow avalanche of water and trickling in that eventually causes a disruption of the sea ice extent of and around the continent. It's something that hasn't been seen before, but to everything that I've looked at and found, there's never been a time where sea ice has been so profoundly gone. So we have areas like this that, sorry, get rid of that, where sea ice has failed recently as well, and eventually it froths up, it beats itself up, pretty much all this ice, eventually to the point that it gets weighing enough to be carried away as fine particulates that eventually melt. A lot of melt. You see here, you can see the sea ice, but the problem comes when we use a time lapse to look at it, is that we can see just how quickly the ice is melting and how quickly it is rotating out and how long it's taking for it to freeze again. You see that? This sudden jump of, this is all fresh water here. Fresh water that's raining from, because you can see it here. So it's more like a shower curtain. Yeah, it's a shower curtain theory. Let's just call it that. It's a shower curtain theory. Shower, no, I can write it all out. Shower curtain theory. So it's creating a curtain-like effect by speeding off the side of the plateaus, the cliffs, and the shelves. Yes, the ice shelves that would have this steep drop and go straight down. Any water that comes up, that bundles itself up and falls down, is going to hammer any kind of ice or potential freezing again and again and again. Because if something 100 feet away is melting down, why isn't the continent yet melting down? Because it's covered in snow. We can't quite see the ice just yet, continent, but we can see the snow. We can see the density of snow, and we can see peaks that are different in and around Antarctica. Mind you, Antarctica has peaks, it has mountains, some of the highest in the world. They're just covered with ice and snow. At least, you see here. There's another area of severe ice fatigue and failure. And you want these areas, these gaps, Now we're going to take one look over here. Let's go with Sentinel-3. This area used to have a lot of sea ice, especially. I mean, this is in the countries that you would have to measure this, you know. How many Brazils is this in its body? How big is this? It's hard to tell because the ice thickness wasn't there. It's all dissipated. This is a massive area of sea ice that is gone. Mind you, there's a volcano right here. This volcano is named Erebus. It is an active volcano, but no eruptions to speak of that are, you know, like blow away all the ice and everything else and cover everything with fire. No. But this is an area just adjacent to the volcano, and it's no longer covered in ice. I did this in the last video, just make it easier. You can see some of the ice still remains here in January, early January, but all that ice, just like everywhere else, gets taken out, gets pulled out, and it doesn't have any reason to stop because it's no longer able to freeze in power and quantity and numbers. And the two of those aren't present in what I can see of around Antarctica. It is almost hysterical looking. You looking like, okay, yeah, there's a lot of seawater, what of it? But where's all the ice at? Where's the sea ice extent? Where's that kilt I spoke of? It is becoming impossible to find sea ice of and around Antarctica, and line of below the line of Antarctic. Some of these areas look like they were hit by sledgehammers. You can see just the minuteness that gets pulverized into these areas and gets taken away. You see it's happening already, because you can see these are already cracked completely. You're going to have this area that's just going to be taken just like all the rest, because the ice already failed here. The ice has already failed. This is on the 15th. Pay attention, special attention. I'll circle here. Thank you. I hope that comes across. You see January. This ice here went away, got carried out. There's not another refreeze happening since then. So we can say in all these areas that we're seeing where the sea ice extent is not refreezing back to where it was before. It paints a rather grim painting of climate change that's yet to come, because you're seeing a lot of sea ice melting. There's a lot of condensation, precipitation that cycles over and over and over again. And more water will stay in the atmosphere. And that water will undoubtedly heat up in the atmosphere and fall down as 6 months of rain in just a few short hours. This used to be something that when I was younger, you would never hear this. You would never hear this area in Australia received 6 months of rain in just under 3 hours. It's monstrous. They're still dealing with flooding from a cyclone Jasper in Queensland. They were hurting for water, but not as much as Western Australia. But that's another day. No wildfires to speak of when it comes to Australia, at least some that would be large enough to see on satellite that we're using here. But you can see this whole neck area, this, and this, the whole head. It is a fraction of what it was. That's all that is left. That's all that's left here, is what's circled. This is all gone, this is all gone. All these familiar features of Antarctica that you learned on a map are disappearing. This is chaos. And it is happening in front of everyone. We can see day in, day out, this ice is pulverized, this ice looks like it's smashed, and then it gets carried away by the ocean currents and winds. Because it's also poking out of the water, the wind comes up behind it and moves it as well. We continue our little quest here. Just giving a little overlook. You see areas like this, it just comes up to the continent. There is no sea ice extent. There's no reason to have a sea ice breaker anymore because there's no ice to break. It's becoming problematic when solar rays are reflected back into space. They're hitting the sea ice and instead hits that water. It's going to keep hitting that water and it's not going to let up. So if it doesn't refreeze in time before the next cycle, we're seeing a lot of massive, huge losses of sea ice that you'd have to use countries to keep it in scale. How many Berlins this year have we lost? How many Australias? Maybe a couple. Is what we're seeing. A lot of fast ice and a lot of ice that migrates constantly. That's not what we're seeing. We're seeing just a massive pulverization of ice in fresh water. See how far it goes? I'll measure it here. Here. And just the beginning of the month, it was instead here and here. Breaks apart, gets carried away, gets carried off, and all that gets pushed or pulled away. And not too long after, it starts affecting more and more and more. It it is like this is the beginning of the month in February. You see how this divots, it fails down, collapses. We shouldn't be seeing anything like this. I haven't seen anything like this in recent memory of looking at month to month sea ice. It's usually not every day, because usually not a lot changes to warrant incremental update video, but now there is. So this channel here, I gravitate towards climate change and unfolding calamities. That we're seeing all of that. It hit every checkbox that there would be on what I would have as a need to dig deeper into that, need to keep our eyes on it, because this is Antarctica failing. Antarctica is too big to fail. But it can fail. It might be failing. What we're seeing, the untold amounts of sea ice loss. You can only see the square meters on the surface, but again, we don't see the depth of what the sea ice has gone. Because we're thinking like, okay, just a few inches, right? Maybe a few feet in some areas. Not really something that's known. A lot of the sea ice comes and goes, fast ice, but much of the ice that connects to Antarctica is gone. Like all the way up to the not cliffs. I call them cliffs because that's really what they're going to be now, because they're going to be one after another failing. It is a scary amount of ice. As we continue to look. I'm sorry, I thought my chat was working on my OBS. I missed all these chats. Water volcanoes are difficult. Submarine volcanoes. I have seen one of my older videos from August or so had a ruby seamount that you could see all the swirls of the eruptions that eventually gets carried off into the ocean. If I find that video, but yeah, Western Australia having floods too. It's a lot of rain. I don't think the solar flares melted quicker because, well, if the solar equivalent of power hits the I was trying not to hear myself. My audio was playing back at the same time. It's a tremendous amount of sea ice loss. Again, we're talking about sea ice that's been there for a long time. The sea ice doesn't just come and go as it pleases. We would have to go back only just a few months. You see this here. Okay, now I pop that out. Yeah, the solar activity will definitely have a hand in melting it quicker. Great white sharks getting eaten by a larger shark. There's sharks that are larger than great whites. They're called, gotta get this right. Six-gill sharks. They're called six-gill sharks. You know, they get pretty large. There's a lot of YouTube videos you can see on six-gill sharks for like undersea documentation of just how large they can become. Sharks are amazing creatures. Where was I? This is looking at massive amounts of sea ice that are clacking together. Like you know, we can probably narrow it down by looking at when the latest big outburst and latest solar events happen. But the solar events don't happen all at once. I've always been learned about this is that solar waves that come out of these eruptions on the sun come out more like this. So kind of like a net. And eventually it comes into a heliosphere, which it has to get wound up in before it meets a velocity that will be able to enter into our atmosphere. It's the whole thing. But to know, like, just because like an X1 burst happened on the sun doesn't mean, you know, immediately. It takes time for these to happen. So they can affect a lot of different things like radio broadcast frequencies, and but saying like this could be the work of or the result of increased like sunburst. I'm struggling to try to remember what the name of it is called. Solar flares, X-class solar flares, you know, things like that. But again, if they're not immediate, and whenever they happen, they're already have all their power just eaten by the planet's atmosphere and this whole heliosphere that goes around and around. So you would take that and it would apply it over the planet, and you would see a lot of little drizzles of green light going all over the place, or orange or amber. Those are the northern lights, which can happen anywhere on the planet. They're not just in the northern lights, but when they happen in the North and South Pole, it's pretty incredible, and like in the Midwest to be able to see it just by looking up these days. That's not something I think I've ever remembered ever happening, is looking up like, oh, there's solar lights and I'm in the Midwest. Pretty incredible. Water sharks and land sharks. See if I can get a better image of this. See, like sea ice didn't used to be something that I would have to keep incremental updates about. But July was the hottest year on record, which became the hottest oceans and seas on record that turned into the hottest rivers. This all flows, but having a tremendous amount of ice melting in a rapid succession. Yeah, radiation storm. They can cause blackouts for like communications, like handheld and stuff like that. Or bigger yet, make power outages and stuff like that. But again, it's like the way that the Earth absorbs these solar flares. It's like more like a vacuum. It gets sucked up into it, and it gets spit out all over our atmosphere from the heliosphere. That's how I remember it. But I don't think it's incorrect. It's probably technically very incorrect, and I'm oversimplifying it. But it's there's no way of knowing like are these solar flares going to affect. But I will say that solar activity, when it picks up on its way into 2026, the water is what absorbs the heat, and that's going to be keeping all this sea ice from connecting back with the continent. The sea ice extent is what we're talking about that is missing, and that's the kilt of the person that you're looking at. And it gets to be quite revealing when you just look at how absurdly without ice so much of this is happening. Yeah, now getting back to this area again, but in a different satellite. Might be able to see it better here. Here it is. This is, I didn't measure this area. Right here. This is what's coming out. A bad tooth. But these aren't areas that I remember not seeing sea ice. So it's my pull pad out of there. These time lapses, they tell a lot of stories. But one thing is for sure is that this ice that came out before this is only just over right here. Right here. It gets pulled out, it goes out. And then eventually it melts and gets smaller and smaller. It just breaks apart and breaks apart more. So there's a lot of cloud coverage, though. It's right here. Big breaks in the beginning of February. Right here. And this ice gets taken out, and it doesn't get replaced by ice that's frozen because the water that's left there is absorbing too much sunlight to refreeze again. So we're seeing alarming areas that we just looked all across. I would have to go back months to be able to find the kind of sea ice that you would expect to see when you visit Antarctica. But as it stands right now, the majority of the sea ice that is surrounding the continent is exhausted. And the cycle continues. So this is the last. It's actually a really great image. You're able to see just how far it goes. It breaks, craters. And these two very giant, because I'm looking at a height of 50 kilometers. That's the scale of the that I'm looking at. Back one. And it's like hundreds of kilometers like, that we see in all the sea ice as bumping out and bumping up. And we see areas that we have like a waterfall, more like a shower curtain effect that is causing all this sea ice to get pushed out. It's something that I will continue to look out for, especially A23A. Oops, sorry, left that on there. This is that very same iceberg that is one that came out, that collapsed out of the 80s and just still made its way after so many decades, is able to be seen in the Scotia Sea. You can see it appearing here in the south. If it's, yeah, here, right here. You can see it turn and tilt. Keep this right here. You see how it literally just continues to spiral. It doesn't flip, it doesn't quake, it doesn't do anything like that. So that tells me that it could be possibly very long. It's longer than it is wide. And we're talking about some 80 kilometers from one side to the other. No telling it's depth, because there's one thing that I can say for certain about this iceberg is that it has not flipped, it has not rotated or tumbled. We're just seeing it spiral further and further out until eventually it either hits the seafloor and melts, but there's no telling exactly its thickness. That's the word, it's thickness. We can see it floating, we can see it rotating, but unless we can see visually it pop up, but even if it pops up and we can see a quarter of the iceberg here on this side, let's say this is only like, you can see us caverned out. It's not, you know, like only 40 feet, because you'll have like another 60 feet on this side, but this side comes down to another 150 feet. It doesn't make sense. Ice has the most unusual properties of anything. So to assume that this thing isn't being anchored down by a long root, I would say this is the biggest iceberg on the planet, the biggest freshwater anything on the planet right now is this floating into Scotia Sea towards the South Georgia Islands. Like, this thing, to make it even better, would have to sail into a volcano that's erupting. That would be spectacular, I'm sure. Like an iceberg sitting next to, I believe, a volcano is called Michael in the South Georgian Islands there, in the very South Atlantic. But this thing is not in the Atlantic Ocean yet. It still has an entire sea that it has to travel. It has a long way to go, but again, this thing wasn't making any strides anywhere. This thing was stuck for years, decades, and it's just recently that it's unthawed and given a whole new path of life. Among all the other giant pieces of ice that is pulverized, as we're seeing here too. It's you know, it looks like somebody went 50% of all ice gone. Now that we're looking at a much higher scale, we can see things that would normally get lost because we can see daily screenshots, or not daily snapshots, that's what snapshots of sea ice all around the continent. And it's very easy to say, okay, from this side, easy to say like, okay, from this point here to this point A to this point B, we can say that this amount of ice went away. And then we get the area of the ice that went away, but it's not true because all this ice breaks apart and all that ice goes its own way. And as we're seeing right here, it's just another again, this is south of the Falkland Islands, Argentina and all that up here. This is where we're looking at. It's a parade of ice. You can see all of it. While the ice itself is reflective, solar activity, sunlight won't get blocked out as much, and they'll start heating up the water. And you start seeing separation like this happening. It's not able to reach itself again, its own natural cleanness. As we continue to look, just going around the, because you know we were looking at this earlier. This is probably the most dramatic example of sea ice loss that I can find. Is all that white is what is sea ice, and blue is open waters, and you want more. You want, absolutely you want more. Let's go to, this is November 2023, just last year. You can see that how it dances around. There's a dramatic shift in the amount of sea ice extent. It is not just in any particular region of Antarctica, because I just showed you, everyone, by going around the continent itself, the entire South Pole, where the sea ice extent would be met. This is what you would normally look at when you're trying to sail to Antarctica. It's a colossal wasteland now. Just bobbing icebergs. And this is from November to December, already becoming very drastic in its changes. And we go to 2024, year to date. And we just see it getting less and less and less. This is what's called Lima, Landsat Image Mosaic of Antarctica. For this, we can use it to look at parts of Antarctica that would be easier to see on a flat map. So you have the whole like center in the center hole of Antarctica. You would get a better sense of like snow. You see a lot of the patterns in wind in mountainy areas. Mind you, Antarctica has some serious mountains. Maybe this will be easier. This is called REMA. Forget what the R stands for. Okay, here's Deception Island on the left side up here. Might take a minute to load, I apologize. But we're wanting to find any... No, that looks the same. Here it is. So this is looking at it back in time. This is the area that's missing now. It just updated a little bit, but not to what we were seeing before this. A lot of smashed ice and open waters. Two things that really we should not be seeing when it comes to Antarctica. But it is, you know, most of the continent is seeing significant sea ice. It's not only the area that's south of Australia or only the area that's south of Argentina. It's all around. And, you know, when it comes to water, the hottest Earth on record globally was last year, I believe, in July. Turns into the hottest waters, oceans, hottest seas, and all that water, all that heat is absorbed for other purposes and other means, other life forms take that warmth. But when you have the Earth heating 1.5 C or higher, we're not seeing the full effects of what 1.5 would have been until, there's no telling, I think it's probably within the last few weeks, especially these increases in sea ice, decreasing in sea ice of and around Antarctica. We can go looking at the latest snapshots of Antarctica and continuing to go around the continent. But it's hard for, it would be difficult to look at this and go, no, that's not what's happening. You know, I don't want to fearmonger. I don't want to spread any kind of disinformation, which I'm not. This is what we're given. This is the same satellite image that anybody pulling this date and time, this satellite that took this image, would be the same that they would see. Not that we're using AI to cover up any kind of links, not trying to do anything besides, okay, here's the planet, and we can use these satellite technologies to get a better view, and it's up to us to configure it and to look at, because you can use a variety of different scripts using Sentinel Hub is what I use. It's no longer free, which I didn't know, because people that have free accounts, they get locked down. But there is another alternative. I don't remember what's it called. If you go to the other Sentinel Hub, not the EO browser, but the other browser that's more like the Playground, Sentinel Playground, I think it's called. that'll leak you to the most recent that they recommend. But this, I thought I pushed play already. It's a lot of cloud height. It's a lot of absurdly fast winds. Play. It's getting harder to find sea ice. Is difficult because, you know, I'm not doing this like, oh yeah, I really hope that I find nothing tonight. You know, I really hope that, oh look at that, there's a entire giant sea's worth of ice that's frozen over. Good. You know, it's not that I want to just talk about bad things, but with this channel I wanted to talk about global things on a global scale that are happening. So this being one of the most powerful presentations that I think that I can put forward is just how much ice is gone. And it's a lot of open water, a lot of blue that's left. And it's been a month now in some of these areas without refreezing. Unable to fetch time lapse. Let's see if it actually does pop up. There. Good. This is from January to the latest. And again, like, this is what we're looking at. The entire continent that's being chewed. There's other temperatures that are abnormal, but we're just looking right now at sea ice concentration and not trying to get too distracted. That's not hard for me. Thank you for sharing. Thank you. Wow. You're being happy. I wouldn't say scary times, because I mean, it's just anybody can look at this kind of information themselves. It's pretty wild. We can see anywhere on the surface of the planet in just a few clicks, and see the last few days of that area. It's pretty wild, but nothing have I seen more wild than this, because this is just like in the other area that we were looking at. It's a huge amount of sea ice extent loss, and it's been since January. That hasn't. We can go back to November like before. Back. Hopefully it doesn't crash or anything. That's a lot. Oh, there it goes. Cool. Okay, just in the beginning of January. Now, okay, good. Okay, here we go. So we gotta go back to November. You can see all the sea ice here. It's a massive amount of sea ice that is gone. And I mean, July was the hottest year on record, so after the heat made its way and absorbed and transferred and, you know, eventually it makes its way into more fragile ecosystems that can't handle or tolerate, you know, that plus 0.15 too much, and it's showing it. You can see all the ice here. Oh, thank you. I gotta make it more of a daily occurrence when I talk about ice, you know, all this, because it is fascinating to me just how quickly this is changing. Because right here, I hope up here shows the date. Pretty sure it's not cut off on the camera, but that is the 11th, November 8th. Right here is all this ice. Up here went away earlier last year. Now this giant region here. I can speed up the process and go like right here. This is the 17th of November. You'll be able to see just how the ice moves, how it melts, how it looks like it moves in a circle. It just pulls out into those currents. See, this is looking further back than I have before. This is November 30th, November 1st, November 30th. The previous videos that I did, it was only, I believe, the last month or so. But all this ice that you're seeing here, up here, right here, this was all connected. And it starts spreading and moving away. It gets carried away, gets flattened by the currents, and then taken away. Like, the scale of what I'm talking about here is massive. Again, I'm looking at it at a scale of 50 kilometers. This right here, I believe that's the extent of it. That right there is a volcano. That is Mount Erebus. We're talking about sea ice here that's magnitudes larger than the ice of and around Mount Erebus, which is an impressive peak, especially for Antarctica. It has some of the highest peaks on the planet. But that is a volcano. So when we say like this sea ice here, when we go back out and we go back to earlier in the year, which play? Let's speed it up a little bit. This is from November to now. Sea ice is not coming back, and this is a very huge area. There's a lot of research stations that are in this area, so research scientists saying that they've never seen anything like this before is pretty incredible. Play that again. Times 8. Times 6. There. You can see how the ice on the north side of it, up here, dissolves, disintegrates, and it pulverizes itself into these little clumps of ice. You can see how it moves. It's very organic. But the problem comes when the ice is pulled away and it doesn't refreeze. And we're seeing this in huge portions. This would be an entire country that we would have to measure this by. We would have to say this is, you know, half of Australia. This is one half of Australia. But as you can see now, going into the new year, all that sea ice gone. It is alarming and very huge in scope. So it's I don't want to ruin anybody's day, because I mean, you click on this link, you should know what you're getting. You're getting like, okay, we're not talking about anything like this end of the earth kind of thing, but we're talking about wait a minute. This area up here on the north side. So I can go up even higher. I don't think it'll let me do it this high though. Let's see. Might take another few seconds to load. No, it won't. I'm gonna look up here on the north side where it looks like there's been more ice loss. So we can see here. Ooh. It's like just pick the right time. You see this giant crack. There's a giant crack that's going through here. All that ice broke apart. This is just north of the area that we were looking at just a moment ago. You can see this ice taken away, hits, pulverizes, breaks more is let out. Eventually, it just grinds itself. Sea ice extent is self-sharpening? Not really, because after it's done sharpening, there's nothing left. It's just pieces. Kind of green right here, interesting. It's an alarming amount. Again, like this is all sea ice here. All this is sea ice. Yeah, we can go back down again. This again, like the scale that we're looking at here, it's a country's amount of water in size and scale and scope. That the amount of sea ice here really can't contemplate it due to it. Like, what's the thickness here? Okay, what's the thickness there? Don't know these things. Now most of it's gone. If it returns, is it going to be the same thickness again? Are we going to know that, okay, this is a tolerable amount of thickness that we have on the ice? We're not going to know these things. Because I'm not saying it's point of past no return, but when these refreeze again, hopefully soon, if it refreezes, because as it currently stands, in a couple of months of just blue. Just gone. Pulverized into tiny little pieces that you can see here. Right here. Go from $27. Almost recent. Sorry, the clicking of my mouse clicking is pretty loud. It must be. So we can speed this down, go back down. So beginning of November, you had sea ice. End of November, all broken apart. End of January, it's catastrophic loss of ice. Beginning of the month, not looking any more hopeful on the return of sea ice, because even if the sea ice freezes, it's not that same free ice that we saw just got carried out in huge quantities. It's not the same sea ice, so there's still going to be new fresh water entering into the seas, entering into the oceans as a result of this amount of ice that's melted. That's the first point to make. Second, okay, here too. All these familiar features that we would see of Antarctica are lessening, because the more permanent features are getting smaller, getting weathered pretty much down. Pop up in a second. Now, this is only going from November to now again. A lot of cloud obscurity here. You can see just these huge shatters. Because this is that same scale at 50 kilometers that we were looking at, where the volcano was tiny. What we're seeing here see separation. Big separation here. Just spun out because it goes like this. He's taken out. These time lapses are important. These time lapses tell us the health of the sea ice. It says where the ice was present before, where it's gone now. And you know, it used to be only a few icebergs, but now there, you know, there's dozens of great sized icebergs that are a danger to mostly anything in its path, and it takes a long time to get around these things too. And you don't want to have your boat hit one of these things. You don't want to hit an iceberg. It's taken out here. I mean, this is dramatic. This area came out, that, and then that is it. This area will follow. The largest freshwater body on the planet, and it looks to be currently melting. At least being hit with heavier winds that are hotter. As the axis tilts and we see more water instead of ice. gets to be a little uncomfortable. Because all this water doesn't just stay in this area where it melts. It's going to go up. It's going to go up, and it's going to be part of the rain cycle. And that's when you get this area in Australia that'll be like 6 months of rain in 3 days. You start hearing these things like, what does that even mean? 6 months of rain in 3 days? What does it even mean? It's one of those things like Vermont last year. A lot of areas have been hit by these rain bombs that just unzip too prematurely and just absolutely drown an area. There's no other way to really put it. It's like since Cyclone Jasper, like in North Queensland, it's just amazing amounts of water that's going all over the place. Like that storm is still there pretty much, it feels like. Oh yeah, your cruise, you're gonna be fine. You should have fun on your cruise. I've never been on one, so you come by and tell us how it went. Because they would know an iceberg way ahead of time. They have different ways to detect them. And some scientists might have much better availability, because I don't know, the satellite grouping here is like the last. You go from like person to a big corporation, and those satellite images are really pricey. Yeah, I would be uneasy on a cruise just because of all the open water. But if you're going like anywhere in the mid-Atlantic and the Caribbean, you know, that should be just fun. Oh, you're welcome. Should be fun. It's like if you ever see like the Antarctic expeditions that you can take along with the science research team. I guess they just make you carry everything. I'm not sure, but it's yeah, this is the south of what we're looking at here, all this sea ice. I mean, there is going to be South Africa and Argentina. They'll see like, yeah, kind of precipitation that were like 6 months of rain in 3 days, 3 hours, doesn't matter, whichever. But you start seeing like 12 inches an hour, 12 inches per hour in raining. There's been a few instances of that, but it's nice. Should be fun. As we're seeing here, this is all that we're looking at. All these familiar features, but we're just looking at the familiar features of Antarctica and using time lapses. You get a better idea of how far the ice has melted or disappeared, because it gets pulled away, I guess, into this vortex of heating and cooling. It doesn't last long. Not like these larger ones that are 10 plus kilometers each or 10 miles each. Like the one that we were looking at earlier was 15 miles wide. Okay, so you just get seasick around the area. You can take pills for that, Dramamine or whatever. Like that seasickness, I get that on a plane. I get very sick on a plane. I don't know why, it's just emotions just doesn't agree with me. Imagine it might be a little bit. I haven't been on like a ship. I've been on boats. Never like a giant ship. This is a painting. Pay attention. This area right here. Dissipating, dissipating, and gone. Replay. That is decimation. And it's brought down. Wow, okay. So that happened. It's all gone. So much ice. So much sea ice. There's no telling, and its thickness to its failure. There has to be some gauge, some relative general idea of how thick these areas can be. But the sea ice extent is always evolving and always moving. 19 days, nice. You'll have fun. 10 days. $10. You'll have fun. Oh boy. This just looks like a ripsaw just went through here. This is November to now. Let's speed it up a little bit. Oh boy. Like pulling away. This area right here in particular. But it's just about anywhere that we would point a camera at, we're going to see not devastation, because it's not like being destroyed. What we're seeing is delirious loss of sea ice. Let's go back a day. Back a day. And this is right here the largest body of fresh water on the sea. It is huge, and that is what's currently probably one of the biggest threats, because this thing hits an island, penguins, is going to devastate that island. You see it moving, just it's turned by waves, hitting it harder, winds. Pretty. It looks like it's going for the. Go back another month. These icebergs like this, I don't think there's another iceberg. I don't see another iceberg nearly this size again anywhere. It's 50 miles wide or 80 kilometers wide, and it is massive. It's getting flipped around, not flipped around like this. It's getting spun around, it's rotating, and it's not flipping. It's not going up on its side. It's not bobbing. It's not eventually reaching any point in time where I can say that this thing flipped. Which is really unusual to think about an iceberg like that just is always flat on it like a bed. Just the same geometry that it's going to be for the last like 3 decades, I think. This thing has been scuttling around near Antarctica, but only recently did it break free, and is it now just causing all kinds of threats. Dirty well water. This is the largest iceberg on the planet. A23A. pretty massive in the scale of which we're looking at. Here, this is the actual continent of Antarctica. We're seeing here this giant shelf. It's more dramatic the more recent these become. Right here, this is what it looks like. This giant sheen came off the top of Antarctica, and just this giant band of water and ice fell on top of, like somebody's giving like a elbow drop. Just like an elbow drop in the water. So this shower curtain theory, that it is creating this elaborate extension of itself, that it's warmer than the water it's hitting, it's warmer than the ice that it's hitting, so it's pushing it away and it's not able to freeze. So it's like just resting a curtain over it. And that's what we're seeing here. And we're starting to see a lot of ice getting pulled away here. And that ice, you can't take water that's just barely cold and say, okay, that's going to refreeze soon. You can't. Like, there's no way of looking away at this problem any longer. It is here. It is something that we're going to have to deal with very soon. And, with sea level rise, it's a scary thing. But I'm not thinking sea level rise here. Not yet, because the sea ice extent, that displacement of ice and water would be hopefully a push. So we're not seeing an actual increase in sea level water, because we've had the density of the ice resting on the surface of the water so long that the amount of ice that we're seeing melt isn't going to dramatically increase the sea level. But again, there's no telling the thickness of the sea ice extent that melted that we've been looking at since November of last year. There's no way of saying that this ice was 6 feet thick here and 3 feet thick here. And there's no way to formulate, to have a formula that would be a really complicated endeavor to try to figure out percentage of ice, because again, you're just measuring the area on top that we can see, like we're seeing here. There's no way to look at the iceberg and say that it's 30 feet long, because they are strange shapes that you might have like steps on it. So you'll have one side that's like half the size, and then there would be this gap, and it'll just continue the rest of the way. So they're not exactly just like a long beam or a cube. A very complicated geometry that exists on the other side of some of these ice patties. You can see it here too. Yeah, it's pretty amazing. It's right here. It pulls away. I don't think we looked from November. This is the largest gap I've seen so far. I guess massively pulled away. You see the detachment of ice to continent becomes greater. It hasn't looked like this in months. Let me go back another month, December. You see they're going to be holding better. Yeah. You see the thickness is there in December. What we're looking at here is the connection of water ice to ice shelf in Antarctica. And its deterioration. And this is this is 70 kilometers. Okay, this is 70 kilometers or like 40 miles. That gap here we're looking at is 40 miles or 71 kilometers or so. These aren't little gaps of sea ice extent to meeting the continent of Antarctica. These really aren't. And we see areas here where it's a lot of snow and it's tall peaks. Not too far from the Falkland Islands, this ice can melt and be carried away. These are not small gaps. These are not normal. Let's go back again. You see it turn, pulled away. Unfortunate looking. We're just going around Antarctica and clicking and making time lapses and making a judgment of where this ice looks pulverized already in December. I got carried away pretty quick. Go back again. It is alarming. Going back over this area again. You can see this is already breaking up right here and right here. go closer here. There we go. That's what's missing. This giant area right here of sea ice. It's getting weathered down here. Let's push play. See it all crumple and break apart. A little slower. Not that slow. And all these pieces of ice get carried away too. See, this area right here fails pretty hard. See this rib-like break. And the sea ice eventually is carried away, melts. This is what it was in December. Within 2 months. But it's not even to say that this area above it, in the north, gets pulverized first. See here. First little piece of failure there. Play. It happens very suddenly, dramatically. Explosion almost. We have here on the 26th of December. 25th of December. Christmas Day. Some people. And this is gone in a week or two. The rest of it gets pulled out. And there's no more sea ice in this area. And it becomes mouth. It is another feature. Let's look at this area here. And push play. That could be normal seeing this here. Alright. I thank you all for joining me here. Thank you all for watching. If you could please like the channel, I screwed up. Please like the stream and subscribe to the channel. It helps me out immensely. It motivates me to continue looking, continue monitoring, and You know, these incremental updates might be helpful to some people. Alright, thank you all for watching. Please take care of yourself. Thank you. Well, love to see you back again. All out too. Thank you. Thank you for your support. Thank you all. Have a good night.